Now this is the orbital diagram for your Z out distortion. So it remains the same up till E2G and T2G splitting. But after that, when Z out distortion occurs or when Jahn Teller distortion occurs, the EG and the T2G, they further split. And after splitting, what happens in Z out is that the dz square, it gets lowered in energy. If this is your average energy, then the dz square is lowered in energy, whereas the dx square minus y square orbital is increased in energy. And similarly, in the T2G, the dxy is increased in energy and the dyz and the dzx, they are decreased in energy. This is the Z out distortion. Similarly, we have the Z in distortion also. Z in distortion is the complete opposite of the Z out distortion. Up till EG and T2G splitting, it is the same. After that, when the further splitting of EG and T2G occurs, then in that case, the dz square, that is increased in energy, whereas the dx square minus y square, that decreases in energy. And in this case, the dyz and the dzx, they are increased in energy, whereas the dxy is lowered in energy. So these are the orbital diagrams for your Z out and Z in. So which complex is going to undergo Z in, which complex is going to undergo Z out, that depends upon which one, Z in or Z out, is going to provide more stability. Like let's see for your D1 configuration. This is the Z in. Let's see what is going to happen if we put a 1 electron, that is D1. 1, 1, 1, 1. Okay. So what did I tell you? I told you that the Jahn Teller distortion, it is there for removing the electronic degeneracy. In this case, there was electronic degeneracy because it was unsymmetrically filled. There were two more options for the electron to go into. But after splitting dxy, dyz and dzx, now there is no electronic degeneracy, right? Because there is symmetry. There is only one orbital, and in the one orbital there is one electron. So there is symmetry. There is no other option for this electron to go into. And obviously it is going to go into dxy and not dyz and dzx, because dyz and dzx, they have a higher energy. So you can say that the electronic degeneracy is removed as well as the energy is lowered. T2G is present at a higher energy than the dxy. So energy is also lowered and the electronic degeneracy is also removed. So you can say that this is like killing two birds with one stone, one thing. Next, let's see what would happen if we have Z out configuration in D1. 1 electron, 1 electron, 1 electron, 1 electron. Our entire Jahn Teller distortion occurred to remove the electron degeneracy. But if I take Z out, if the complex undergoes Z out distortion, electronic degeneracy is not going to be removed. It is still unsymmetrically filled. It is still electronically degenerate. So D1 configuration does not undergo Z out, it undergoes Z in, because Z in is the one which is going to remove electron degeneracy as well as lower the energy. In Z out, okay, energy is lowered but the degeneracy is not removed. So D1 configurations undergo Z in. Then we have the D2 configuration. For the D2 configuration, let's see if the Z in is more preferable or the Z out is more preferable. So this is Z in. D2 means that 2 electrons in D. So 2 electrons here, 2 electrons here. So T2G is electronically degenerate. So 1 electron will come to dxy, and okay, pairing does not happen. Whenever there is further splitting, then I cannot pair up the electrons in dxy because this energy is just very less. So pairing will not occur. The electron will simply go to the higher orbital, that is the dyz. Again, electronic degeneracy is not removed. Here the electron is again electronically degenerate. Electronic degeneracy is not removed. And furthermore, what is happening? Energy is increasing. So energy is increasing, electron degeneracy is not removed. So this is not a preferred thing. Zn is not preferred for D2 configuration. Let's see if Z out is a better alternative for the D2 configuration. D2 and D2. Electronic degeneracy removed, energy lowered. Both of the things are happening in Z out. So we can say that D2 is undergoing Z out and D1 will undergo Z in. D2 cannot undergo Z in because in that case electron degeneracy will not be removed and energy will also be increased. Whereas D1 cannot undergo Z out because if D1 undergoes Z out, then the electron degeneracy will not be removed. So this is how you predict whether a complex is going to undergo Z out or Z in. Now your Z out and Z in and the Jahn Teller distortion, as I said, it is responsible for the stability of complexes. How it is responsible for the stability of complexes, we will see in our next slides.